Today, I will continue my discussion on locating centroid of composite section with cutout holes. Also, in this section, we will see how the change of reference axis affects the coordinates of centroid of the composite section. Let us take the first question. We need to find out we need to locate the centroid of the composite area shown in figure. So here, first we need to fix the reference axis. As usual, we will select two reference axes. The vertical axis passing through the left end of the figure denoted by Y, and a horizontal axis passing through the base of the section denoted by X. Now, to locate the centroid of this composite section, we need to divide the composite section into symbol figures. So here I will be dividing this section into three symbol figures. First one is triangular section, second one is rectangular section, and the third one is a semicircular section. Now from the figure we can see that the third section, that is semicircular section, is being removed from the composite section. We are removing the semicircular section from the composite section. Now let us assume G as the centroid of the composite section, which is at a distance of x bar from y axis and y bar from x axis. Now in order to find out the coordinates of this capital G, we can use the formula x bar is equal to a1 x1 plus a2 x2 minus a3 x3 divided by a1 plus a2 minus a3, and y bar is equal to a1 y1 plus a2 y2 minus a3 y3 divided by a1 plus a2 minus a3. Now to locate the centroid of the composite section, we need to locate the centroid of symbol figures first. For that, we will consider symbol figures one by one. Let us take the first one, that is triangle. So here we will remove the rectangular section as well as the semicircular section, and we will try to locate the centroid of this triangular section. Now how will you locate the centroid of this triangular section? Let us assume that G1 is the centroid of the triangular section. So this distance G1 will be at a distance of b by 3 from the 90-degree corner that we have already learned, right? So it will be 100 by 3 from the 90-degree corner, and h by 3 from the 90-degree corner, right? So from here it will be h by 3, that is 150 by 3. But what is x1 and y1? x1 is the distance of this G1 from the y-axis. Now how will you get x1? So we know this distance. So it is 100 by 3 from the right 90-degree corner. So the balance length will be 100 minus 100 by 3. That is x1. Similarly, you can find out the distance of G1 from the x-axis. So it will be total, we know total height is 150. So 150 minus this distance 150 by 3. So that is y1. So for triangle, area will be half into base into height, which is equal to half into 100 into 150, is 7500 mm square. Y1 will be 150 minus 150 by 3, which is equal to 100 mm, and x1 will be 100 minus 100 by 3. The second one is rectangle. So here we need to remove the triangle as well as semicircle. So I am removing triangle as well as semicircle. Now we have only a rectangle. Now how will you locate the center of this rectangle? It will be exactly at the center of the rectangle, right? So G2 denotes the centroid of the rectangular section, and that will be at a distance of 100 from the left end of the rectangular section, right? Will be at a distance of 200 by 2 from the left end of the rectangular section. But what is x2? x2 is the distance of G2 from the y-axis. So you need to add this 100 also. Okay, similarly, how will you locate y2? y2 will be half of 150 mm, right? y2 is the distance of G2 from x-axis, so it will be 150 by 2, and x2 will be 100 plus 200 by 2. Okay, so for rectangle, a2 is equal to b into h, which is equal to 200 into 150. y2 is 150 by 2, and x2 is 100 plus 200 by 2. Now the last one is semicircle. So for that, we will remove the triangular section as well as the rectangular section. So you can see a semicircular section here. You know how to locate the centroid of the semicircular section, right? G3 denotes the centroid of semicircular section, which will be at a distance of 50 mm from the left end of the semicircular section, right? Okay. And what is this distance? y3. y3 is the distance of G3 from x-axis, right? So what is that distance that we have already learned? Will be 4r by 3 pi from the flat end of the semicircular section. Okay, so for semicircle, we have A3 is equal to pi r square by 2, which is equal to pi into 50 square by 2. There is 3925 mm square. What is y3? y3 is the distance from the x-axis. So that will be 4r by 3 pi, which is equal to 4 into 50 by 3 pi, which is equal to 21.23 mm. Now what is x3? x3 is the distance of G3 from y-axis. So that will be equal to this 100 plus another 50 plus another 50, right? So 100 plus 50 plus 50, which is equal to 200 mm. Now we will write all the values obtained in the tabular format. Okay, you can transfer all the values here. Now you try to find out all the areas. So here, since we are removing the semicircular section, we have to give a negative sign here. So what will be the total area? Total area will be 7,500 plus 30,000 minus 3,925, since we are removing this semicircle from the composite section. So total area will be 33,575. Similarly, you can find out AI xi. Since area is negative, minus area into xi will give you a negative value here, right? Similarly, for ai yi also you will be getting a negative value. Okay, now you try to find out the sum of these three values. Okay, that will be 5715025, and here in the last column you try to find out all algebraic sum of all these values. That will give you 2916593.75 mm. Now to locate the centroid, we can use the formula x bar and y bar as mentioned earlier. So that will be 170.21 mm from y axis and 86.87 mm from the x axis. Now let's solve the next question. So here there is a small difference. The reference axes are already given in the question, and we need to locate the centroid of the composite section or composite area about the given x and y axis. Now from the figure you can see that a rectangular section as well as the semicircular section lies in the first quadrant, whereas the triangular section now lies in the second quadrant. Here we will see how the change of reference axis affects the coordinates of the composite section. Let G be the centroid of the composite section, which is at a distance of x bar from y axis and y bar from x axis. Okay. Now I am going to write the general equation for finding out the coordinates of capital G. That is, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3, and y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Now since we are removing the third section from the composite section, that is semicircular section from the composite section, this a3 becomes negative. Okay, so we will put the negative sign while calculating the area. Now, in order to locate the centroid of the composite section, first we will consider the triangular section. So for that we will remove the rectangular section and semicircular section from this composite section. Now how will you locate the centroid? So let G1 be the centroid of this triangular section. Now this G1 will be at a distance of b by 3 from the y-axis, right? That we have already learned. B by 3 from the reference y-axis. So this is our x1, 100 by 3. And what about y1? So for that, first we need to find out the distance of G1 from the top surface. So that will be 1/3 of 150. That is 150 by 3. That is from the top. We need the distance of G1 from the x-axis. So it will be 150 minus this value. Okay, so for triangle area, A1 is equal to half into B into H, which is equal to half into 100 into 150, which is equal to 7,500 mm square. What about Y1? Y1 is measured from the x-axis, that is above the x-axis, right? So it will be positive 150 minus 150 by 3, which is equal to 100 mm. Now coming to x1, what is x1? x1 is the distance measured from y-axis. So here G1 lies in the second quadrant, right? In the second quadrant, we can see that this distance, this horizontal distance will be negative. That is the difference. See, since the centroid lies in the second quadrant, the x distance of G1 will be negative, but y distance will be positive because it is above the x-axis. So here, when you write x1, you have to put a negative sign. Understood? Okay, so this will be minus 100 by 3, which is equal to minus 33.33. Now the next one is rectangular section. So we have to remove the triangular section as well as the semicircular section. You know how to locate the centroid of this rectangular section. It will be exactly at the center of the rectangular section, G2. So what about x2 and y2? x2 will be half of this 200, that is 100 mm from the y-axis, and it will be at a distance of 150 by 2 from x-axis. So this is very simple. So for rectangle, A2 is equal to B into H, that is 200 into 150, that is 30,000 mm square. Y2 is equal to 150 by 2, that is 75 mm, and x2 is equal to 200 by 2, which is equal to 100 mm. Now the last one is semicircular section. So we need to remove the triangle as well as the rectangular section. Now you know how to locate the centroid of the semicircular section. So G3 will be somewhere here. So what is y3? Y3 will be 4r by 3 pi from the x-axis, and x3 will be at a distance of 50 plus 50 from the reference y-axis. So since G3 lies in the first quadrant, both x and y will be positive. Okay, for semicircle, A3 is equal to, we are removing the semicircular section from the composite section. That is why we are putting a negative sign for area. So pi r square by 2, which is equal to minus pi into 50 square by 2, which is equal to minus 3925 mm square. Since we are removing the semicircular section from the composite section, we are giving a negative sign here. But x and y coordinates, since the point G3 lies in the first quadrant, both will be positive. So y3 is equal to 4r by 3 pi from x-axis, it is 21.23 mm, and x3 will be 50 plus 50, right, which is equal to 100 mm. Now we will transfer all the values obtained so far in this tabular format. Okay, so first one is triangle. The area is 7,500. We know that the x coordinate of G1 lies in the second quadrant, so x will be negative and y will be positive. That is why you are putting a negative sign here, minus 33.33. So AI, xi also will be negative. So minus 249975. Since yi is positive, AI, yi will be positive. Now coming to the second one, rectangle. So area, xi, AIXI, yi and AIYI all will be positive. Now semicircle, since we are removing the semicircular section from the composite section, the area will be negative. Okay, now G3, since it lies in the first quadrant, both x and y coordinate will be positive. So 100 and 21.23 will be positive. Now AIXI will be negative. Why? Because area is negative. So this will be negative. Similarly, AIYI also will be negative. Now you try to find out the algebraic sum of all the areas. That will be 33,575. You find the algebraic sum of AIXI. Okay, so you'll get this value. Similarly, you find out the algebraic sum of AIYI also. Now using the general equation, we can find out x bar and y bar. So this value, sigma AIXI, which is the algebraic sum of all the values, that divided by algebraic sum of area will give you 70.21 mm from the y-axis. Similarly, you can find out y bar also. This value, the last value, divided by the algebraic sum of areas will give you 86.87 mm from x-axis. So by comparing the values of x bar and y bar obtained in this problem with the previous problem, you can understand that as we change the position of the reference axis, the values of centroid also keeps on changing.